All right, as you can see by the two gray dots on the bottom, on a losing streak. Third time's the charm, I guess. Let's do a Khan Academy problem from the set. Calculating speed and mass using conservation of momentum. So we have 2 kilos moving to the right at 10 meters per second on a frictionless track, and we collide with 3 kilos, initially at rest. The 2 kilo cart has a final speed of 1 meter per second to the left. Oh, okay. So, doesn't say they stick together. Okay, so let's see. We're just going to do m1v1 before the collision plus m2v2 before the collision. Is m1v1 final after the collision, pardon my sloppiness here, plus m2v2 after the collision. All right, so let's throw in what we know. Before the collision, we have 10 kilos moving 5 meters per second. That is 10 kilogram meters per second. This other guy, the 3 kilos, is at rest before the collision, so he contributes no pre-collision momentum. The final momentum of the 2 kilo is 1 meter per second to the left. So hang on. This guy comes in real fast right and then real slow left. The change in momentum of this guy has to be equal to the change in momentum of the other guy. Well, whatever. Maybe that's a more complicated way of looking at it. The total change for the light guy is, let me see, 5 to negative 1 is 6. So I'm going to guess 6 times 2 is 12. The change in momentum of the little guy is 12. So I'm going to say this guy has to be leaving at 4 meters per second, because 3 times 4 would be 12. But let's algebraically sort of prove that to ourselves. 2 kilos multiplied by negative 1 is the final momentum of the light guy. The heavy guy, what is the final speed of the 3 kilo guy? Okay, so let's see if my mental math is correct. V2F. We're going to do 10 minus 2 is 8. Whoa, my mental math is not correct. So hang on, is that right? No, it is correct. I'm an idiot. I need to add 2 to both sides. That would give me 12 divided by 3. Sorry, this is why you don't do algebra in your head. 8 and then plus 2. You have to undo the subtraction over here. 10 plus 2, all divided by 3, is indeed 4 meters per second. So, like I said, one way of thinking about it is the change in momentum of one has to be equal to the change in momentum of the other, because the same force acts for the same period of time. So the impulse on these two cars is the same. If the little guy goes from 5 to negative 1, that's a change of negative 6 meters per second, times 2 is negative 12 meters per second. So if the 3 kilo guy starts from rest and has to experience a change in 12 kilogram meters per second, that means he has to be going 4. 4 times 3 would give you 12 kilogram meters per second. So the algebra sort of mathematically confirms my intuition. And see, I'm going to Stanford. Now at least I can get 2 out of 4 right. Thanks for watching. See you in the next video.